Let us see the basic circuit realization for this field effect transistor FET. So we have a different mode of operations for this FET, right? When VG is equals to 0, right? And when the VGS is present between pinch of voltage and 0, right? Okay. And when VGS is greater than pinch of voltage, right? So when VGS is equal to 0, we will get maximum drain current, right? That is shorted drain current, right? IDSS, right? When VGS is equal to 0, we will get ID, drain current ID, that is flowing from drain to source. That is equals to IDSS, right? Okay. And when VGS is means get to source voltage, that is applied within get to source is present between 0 volt and pinch of voltage, right? In that case, the drain current that is flowing from drain to source terminal, that is going to be present between 0 to IDSS. Okay. Yeah. 0 to IDSS. This is linear region, right? This is saturation red box and this is linear region. Next, again, when get to source voltage, right? Get to source voltage is greater than pinch of voltage, right? At that case, right? When get to source voltage greater than pinch of voltage, drain currents becomes 0. Means the channel has been pinch off. Oh, sorry, yeah, channel has been so pinch off, or this uh, get to source is applied with pinch of voltage, right? So because of that, the current becomes very less or near equals to 0. So ID is equals to 0. Okay. So these are the three operations: saturation, cutoff, linear region. Okay. Yeah. Okay. Similar to the relationship between the input current and the output current of the BJT, right? It was like, IC current, right? That was a collector current. Output current was I collector current, and input current was IB base current, right? And beta was the amplification factor, right? So output current was equals to amplification factor beta into input current IB base current, right? Okay, so these were the equation for the BGT. Similar one will be formed in case of JPT. So we will get ID. Okay, ID equals to IDSS into 1 minus VGS upon VP square. Okay, now we have to observe that within this equation, yeah, the ID current whose value is going to present between 0 and IDSS that we have learned here, right? In this case, 0 and IDSS in, yeah, between 0 and IDSS, right? So that's why there is going to be a function 1 minus VGS VP, right? So whatever the current that is varied, right, is completely dependent on our VGS, right? So VGS, right? Okay, and up to what? VP. So this is how VGS is going to control the IDSS, and so we will get the current ID flowing through the drain to source terminals. Okay, so this is what the control variable 1 minus, yeah, VGS VP. This function is going to have this VGS as a control variable for this current of drain flowing from drain to source, right? Okay, so this is how we can see the relation between these currents of the BJT and the FET, right? In BJT, right? In BJT, we have the controlling, yeah, variable is what the base current timing. But in case of FET, we have the controlling variable. Control variable as voltage get to source voltage. So BJT is current control device, while JFET is what? Voltage controlled device, because whatever the voltage changes at VGS will reflect in change in current ID. Okay, right. So this is yeah, this is the photo of William Bradford Shockley. Okay, he was the co-inventor of the field effect transistor. Okay, so there are various kind of semiconductor devices was actually invented by Shockley, right? One of the very famous kind of devices, Shockley diode.